All right, you stuck around. This is for another example. So I really think it's important to identify those really five. Well, first thing, let's write down our mapping notation. We take x point xy, and really we transform it into x comma the square root of y. So let's look at the question. Given the graph 8 minus x squared divided by 2, we're going to graph the square root of that. We're going to use this notion of this mapping notation to help us out. So 5 important facts. Number 1, the square root of a negative number does not exist. So if we ever see on this function a y value is negative, our function won't exist there. 2, the square root of x, the square root of any number is greater than the number itself whenever that number is in the domain. Oh, that's wrong. I have to be very particular about my inequalities here. Whenever x is, whenever y is between 0 and 1, our function, our square root function has to be greater than the original function. But it must never exceed 1. Third interesting fact, the square root of 1 is equal to 1. Fourth fact, I don't know. Well, the square root of 0 is equal to 0. I messed up that one. And let's just see where we end up here. Given this graph, let's graph the square root of 8 minus x squared is equal to 2. This graph is already mapped out for us. I'm going to put little arrows here to signify that it's continuous. I'm going to focus on my mapping notation. What I notice here, particularly, and here, my y values are negative. So the square root function won't exist in this domain. However, I'm going to go after my stationary points. My y value is 0. So wherever I see my y value is equal to 0, these are stationary points because the square root of 0 is 0. Similarly, for 1, what confuses students here is, Mr. Morin, I don't know the x value there. Well, neither do I, but I certainly know the y value is 1. If I want, I could algebraically solve for it, but that seems pretty beefy, and I'm not really interested in doing that. Anyways, my function reaches a maximum over here, 8. So it seems natural that this point, 0, 8, I'm going to transform that. So 0, 8 gets mapped into another point called 0, the square root of 8. Now, square root of 8 is very close to the square root of 9. But it's going to be less than the square root of 9. So I'm just going to make it there. I'm going to graph my points now. I'm going to make sure. My y value is less than 1, but greater than 0. I have to make sure to the person marking, I show that my function is greater in this interval, my square root function. And then, if you want, you can say, well, my y value was 4 there, so I'm going to make it 2 there. So I'm just going to... There's my maximum. My y value here was 4. I'm going to make it 2 right over here. Now, I think I might have made a mistake here because my y value was 4 and my x value was 2.9. So maybe I'm just going to move that over there. My y value was 4, take the square root, becomes 2. So now I have some points on my graph. Now there's the tricky one right there. I have to ensure that my function is, my square root function is greater than the original function. It should be all nice and smooth. I hope that answers the question what the function looks like. It is not very nice. But here, my domain, my domain of the square root function of this function is going to be x exists such that it's stuck between -4 and 4. My range, now I'm going to take a look. It goes from 0 all the way up to this point here. Now this point is, I'm just going to write in a different color, the square root of 8. Yuck. Anyways, let's just do some quick questions. Let's see if you understand this. If y is equal to f of x and has the following characteristics, take out the double word, comment on the possible values on y is equal to the square root of f of x. So if f of x has a y-intercept of 5, x-intercepts of -3 and 6, the range goes all the way from y is greater than -3, and y is element of the reals, and the domain is x is greater than -3. You know, this is tough because I take some point xy, and if I'm taking the square root of the function, it's x comma the square root of y. Now the y-intercept on, if this is my square root function, well, the y-intercept really says is this, 0, 5. It occurs at 0.05. So the y-intercept would be 0 comma the square root of 5. The x-intercepts are -3 and 6. So really, those are my points for my x-intercepts. So they're going to have the same x-intercepts. Also, we can see this from, because they're stationary points. Our x-intercepts are zeros, are stationary points. If my range goes from y is greater than -3, so that means just pictorially, I need to get a handle on it. So here's my Cartesian plane. My function can be goofy, whatever it might look like, could look like that. But the lowest y value is -3 and it goes up. That's my range. However, in a square root function, we have to restrict from being negative. So that means that my new range, basically anything that's negative, we lop off. Done. But it goes from 0 all the way to infinity. And then I'm going to apply my square root function. Now this is terrible math, right? But it goes from 0 to the square root of infinity. And I'm just going to say that y is greater than or equal to 0. There. I shouldn't say it's terrible math. I just showed my thoughts inside my head. Right? The domain. I have no idea what the domain looks like. None. All right. Why don't you guys try to identify the following characteristics? I've sort of started preliminary work over here, and I defined f of x is equal to, it's a little bit messy, but f of x is equal to x squared plus 7, and then I can take the square root of that. I can consider my thoughts. So I've just done a quick graph of that, and what I see is that it's an upward opening parabola with vertex 0, 7, it's upward opening, and what I see is that the graph exists everywhere. So the domain of this graph is x's element of the reals. My graph is always positive. And my range goes from 7 all the way up. But now, if I take the square root, my y-intercept, remember, after all, we are just transforming this point. My y-intercept is the square root of 7. My x-intercepts, since y is equal to x squared plus 7, didn't have any intercepts, this will neither. My range, well, this is of my parent function, but I can take a look at this. How does the behavior of the range turn out? Well, my lowest point for this graph went from 7 to infinity. So if I'm taking the square root, it'd be the square root of 7 to infinity. My domain. Here, my domain was x's element of the reals. And since my function exists everywhere here, and it's positive everywhere here, the y values are all positive, that means that when I take the square root, I will get a defined value for all x. So x is element of the reals. All right, this one I believe is a little bit more challenging, so I'll let you have at it. Let's see where you come up with. Please press pause and attempt. Tricked you. So let me just define my function y is equal to negative x squared minus 5. What we see is my function is negative. All the y values are negative. So my function f of x exists, but the square root of f of x does not exist, because this only works when the y values are positive. All my y values are negative. So actually, my function does not exist. Tricky, tricky. Let's go on to the last example. All right. So now we're just given two graphs. We're going to graph the square root functions of each of these. So remember the 5 really important ideas. Wherever our graph is negative, the function, our square root function, doesn't exist. Where we have an x-intercept, that is a stationary point. Wherever y is equal to 1, that is another stationary point. I may choose, since I am going to be using this transformation, I may choose to pick perfect squares. If y is equal to 4, when I transform it, y becomes 2. When y is 9, that's right about there. Your transformed y will become this. That is a beautiful function. This one's more challenging, so I'm going to pick the color green for challenge. All right. If this is my parent function, y is equal to f of x, I'm going to attempt to graph y is equal to the square root of f of x. Great question. Go over those 5 important ideas. Wherever my function is negative, right here, my function will be undefined, my square root function. Wherever I have an x-intercept, we have stationary points. Wherever y is equal to 1, we also have stationary points. Now again, I may pick perfect squares just to make them for the y values and take the square root of it, just to make them nice and easy to manage. So here, y is 9. Here, y is 9. I'm going to move it over here. Now this kind of gets tricky because my function starts here. doesn't exist, nothing exists here. Okay, I'm actually going to draw the left-hand side. I know that my y values are between 0 and 1. So when I take the square root of anything in that interval, my graph has to go above it. And then I just simply connect the dots. Now it should have this nice arc to it. It should not be a straight line. Again, above. Oof, missed. Make that dot bigger. There we are. That's how we handle it. Should have that nice arc. And there's my two square root functions. The reason why I put arrows at the end is because they should have arrows. Any different year, I really emphasize that. Anyways, that's all I have for you on square root functions. I wish you all the luck. Please ask questions. Those 5 very important ideas are important for the whole entire lesson.